In this video, I am explaining about the cardinal points. In that section, I am going to explain how to derive an expression for equivalent focal length of two thin lenses separated by a finite distance. This we have to take two lenses L1 and L2 which are separated by a distance small letter d. Already in the previous videos I explained how to draw the cardinal points. In that video I have explained you to draw the diagram. Here in order to derive an expression for equivalent focal length, I am going to explain the derivation by taking lens L1 first, then lens L2. Then we are going to combine the lens L1 and L2 to derive the expression. Let us start from the first lens L1. Whose focal length is small letter f1 is the principal axis. The incident light PQ is incident at height h1 on the principal axis. This object is at infinity and the parallel beam of light rays are incident on this converging lens L1. Then we know that after refraction all the light rays converges at a single point. That is, all the light rays converges at a principal focus of the lens. So this is the refracted ray. It meets or converges on the principal axis at the point f2 dash. Here f2 dash is the principal focus of the lens L1. The distance between L1 and f2 dash, L1 is nothing but a position of the optic center. The distance between L1 and f2 dash is the focal length of the lens 1, that is f1. Now, due to the presence of the lens L1, the incident light PQ gets refracted along QF2 dash, but in the absence of the lens L1, the incident light PQ travels without any deviation. But due to the presence of the lens L1, the incident light PQ produce the deviation here. So the light ray PQ produces the deviation delta 1. So the deviation produced by the lens L1 is delta 1 here. Now to write the expression for delta 1 here, that is the deviation produced by the lens L1 is given by delta 1 is equals to, this delta 1 is equals to h1 by f1, that is in the triangle, right angle triangle QL1 f2 dash, and this is the exterior angle here. Therefore delta 1 is equals to h1 divided by f1. Let me explain it. So this is the PQ. This is the one straight line, and you have the another straight line L1 f2 dash. I have drawn here. PQ is the one straight line, and L1 f2 dash is the another straight line. So those two parallel straight line, PQ and L1 f2 dash are the two parallel straight line. Another straight line QF2 dash cuts those parallel straight lines. Then QL1 is a straight line, and you get a triangle here. Get a right angle triangle QL1 F2 dash. You know the distance QL1 is H1, L1 F2 dash is F1. The same diagram I have drawn here. So this is the angle delta 1, because the two, you have the two parallel straight line, and this is the line which cuts the two parallel straight lines. Then these are the angles, they are alternate angles. Now these are the alternate angles. Alternate angles are same or equal. That's why we can write here the expression for tan delta 1 here. That's tan delta 1 is opposite side divided by adjacent side. This delta tan delta 1 is equals to h1 by f1. This tan theta, actually I have to write here delta here, tan, the expression is tan delta 1 is equals to h1 by f1. If delta is very small, we can write delta is equals to h1 by f1. That's why I write here delta 1 is equals to h1 by f1. Now let us find out the deviation produced by the second lens. Take the lens L2, the principal axis. Now QR is the incident light for the lens L2, get and that the incident light is incident on the lens L2 at height h2, and that QR incident light gets refracted and it meets the principal axis at the point f2. What is f2 here? F2 is the principal focus of the lens L2, and the distance L2 f2 is nothing but focal length of the lens L2. And in the absence of the lens L2, the QR travels without any deviation. But due to the presence of the lens L2, the light ray QR gets refracted. Therefore, it shows the deviation. It shows the angular deviation. It shows the angular deviation of delta 2. That is the deviation produced by the second lens. Then what is the value of the delta 2 here? Delta 2 is nothing but, that is the same thing you have to use. That is, here it is a delta 1, here it is, sorry, here it is delta 2. This is the alternate angle delta 2. Therefore, tan delta 2 is equals to h2 by f2. Therefore, if delta 2 is very small, delta 2 is equals to h2 by f2. Now, this diagram actually I have to draw in the examination, but I have drawn those L1 and L2 separate diagram to understand the concept. Actually, I have to draw this diagram in the examination to derive the expression. Let's take the lens L1, lens L2, which are separated by a finite distance, small letter d is the principal axis, PQ is the incident light, which is incident at height h1 from the principal axis, gets refracted along QR, and in the absence of the lens L2, it meets the principal axis at f2 dash, and this is the focal length of the lens L1, and absence of the lens L1, the incident light PQ travels without any deviation. But due to the presence of the L1, the light ray gets refracted along QR. Therefore, I have to calculate the deviation produced by the first lens, that is delta 1. Now, what's the formula for delta 1 here? Already I have explained in the previous slide. That is delta 1 is equals to H1 by F1. That's the deviation produced by the first lens. Now, QR acts as the incident light for the second lens. And that QR ray gets refracted from the lens L2 and it meets the principal axis at F2. In the absence of the lens L2, the light ray travels without any deviation. But due to the presence of the lens L2, it gets refracted and it meets the principal axis at F2. Therefore, you have to calculate the deviation produced by the lens L2 here. We know the distance between L2 and F2 is nothing but focal length of the lens L2, that is F2. Now, this is the deviation produced delta 2. We know the expression for delta 2 here. Delta 2 is equals to H2 by F2. We have calculated the deviation produced by first lens as delta 1, deviation produced by the second lens as delta 2. Now, extrapolate F2R in the backward direction. We get a point H2. Now, draw a plane which is passing through H2 and perpendicular to the principal axis. This is the plane, the principal plane. It cuts the principal axis at point P2. This is second principal point. We know the distance between P2 F2 is equivalent focal length. Now, we get a triangle here. We get a triangle QH2R. Here we get triangle QH2R. Now these are the two straight lines here, QF2 dash and H2F2 dash. Those two straight lines coincide each other at the point R. Now these are the two angles which are vertically opposite. We know that vertically opposite angles are same or equal. Therefore, these vertically opposite angles F2 R F2 dash and H2 R Q are equal. So these are vertically opposite angles. Already I have told you to get a triangle H2QR. We have the interior angles delta 1, deviation produced by first lens. Delta 2 is another interior angle, delta 2, there is the deviation produced by the second lens. We have the delta 1 deviation produced by first lens, delta 2 deviation produced by second lens. Now I have the another angle here. This is the exterior angle. We have one exterior angle delta, two opposite non-adjacent interior angles delta 1 and delta 2. Now let us write the expression for, or let us imagine we have a lens, that is we have the equivalent lens, we have the equivalent lens which replaces lens L1 and lens L2. It's called equivalent lengths. It's a combination of L1 and L2. Now, PQH2 acts as an incident light on the lens, and H2F2 acts as a refracted light, and this is the deviation produced by the incident light PH2. This equivalent lens produces a deviation of delta. These have H2 and here P2, and this is F2, and this is delta. What is the length of H2P2 here? The same as QL1. QL1 is equals to H2P2. The value of H2P2 is H1. P2F2 is nothing but the distance, a capital F, that is the equivalent focal length. What is H2P2 here? H2P2 is nothing but a position of the equivalent length. Then what is the deviation delta here? The value of delta is H1 by F. Yeah? So therefore the value of for delta is equals to here, delta is equals to H1 by F. Okay. Therefore, we have derived the expression for deviation produced by the equivalent lengths. Delta is equals to H1 by F. What I have told you, this is the exterior angle delta, and these are the two opposite non-adjacent interior angles. Therefore, the value of the exterior angle delta is equals to sum of the two opposite non-adjacent interior angles. Delta is equals to delta 1 plus delta 2. What's the meaning of that? The deviation produced by the first lens and the deviation produced by the second lens, if we add both the deviations, we get deviation produced by the equivalent lens. Now, let us derive the expression here. We know the value of the delta. Delta is equals to H1 by F. Delta 1 is H1 by F1. And delta 2 is equals to H2 by F2. Therefore, the expression becomes H1 by F, capital F, is equals to H1 by F1 plus H2 by F2. The same equation I have taken in this slide. Now divide throughout the equation by H1. So divide throughout the equation by H1 here. Then we have to divide throughout the equation. Divided by H1, H1 get cancelled, divided by H1, H1 get cancelled. And here we get 1 by F2, H2 by H1. That is the expression. 1 by F equals to 1 by F1 plus 1 by F2 into H2 by H4. Let us take this as equation number 1. Now we have the triangle QL1 F2 dash, the triangle QL1 F2 dash and RL2 F2 dash. These are the two similar triangles. QL1 F2 dash, RL2 F2 dash are the two similar triangles are here. Now the ratio have to take the ratio of RL2 divided by QL1 is equals to L2 F2 dash divided by L1 F2 dash. So I have to take this triangle QL1 F2 dash and RL2 F2 dash. So the ratio of RL2 divided by QL1 is equals to ratio of L2 F2 dash, so divided by L1 F2 dash. Therefore, RL2 by QL1 is equals to L2 F2 dash by L1 F2 dash. Now to find the distance. What's the value of the RL2? RL2 is here H2. What is the value of RL2? RL2 is H2. What is the value of QL1? QL1 is H1. What is the value of L2 F2 dash here? L2 F2 dash, that is find the value. L1 F2 dash, sorry, L1 F2 dash, one of the F1. Therefore, L1 to L2, the distance is T. Then what is the value of L2 F2 dash here? L1 F2 dash is F1, L1 to L2 is D. The remaining length L2 F2 dash is nothing but F1 minus T. Now substitute the value of RL2 H2, QL1 H1, L2 F2 dash F1 minus D, L1 F2 dash, L1 F2 dash is F1. Therefore, the equation becomes H2 by H1 is equals to F1 minus T divided by F1. Then rearrange the term here, we get H2 by H1 is equals to F1 by F1 is 1 minus D by F1. Now substituting the equation 2 in the equation 1 here, we get 1 by F is equals to 1 by F1 plus 1 by F2. The value of H2 by H1 is 1 minus T by F1. Substitute the value here. H2 by H1 value 1 minus T by F1. Okay. Then multiplying the one, now the equation becomes 1 by F is equals to 1 by F1 plus multiply with 1 by F2, 1 by F2 minus D divided by F1 F2. Therefore it is 1 by F is equals to 1 by F1 plus 1 by F2 minus D F1 F2. Therefore we can write the equation as the LCM is F1 F2 here. Therefore 1 by F is equals to F1 plus F2 minus D divided by F1 F2. Now let's take the reciprocal. The equation becomes F equals to F1 F2 divided by F1 plus F2 minus T. This is the equivalent focal length of the two lenses of focal lengths F1 and F2, which are separated by a distance D. Now if you take delta is equals to D minus F1 plus F2, which is called as optical separation or optical interval between the two lenses, then the equation becomes F equals to minus F1 F2 divided by delta. That is in here at this part If you take D minus F1 plus F2 as delta, now that equation, this equation becomes F equals to minus F1 F2 divided by delta. So this is the expression for equivalent power of the two thin lenses. We know that power of the lens is nothing but the reciprocal of the focal length. Therefore, P1 is equal to 1 by F1, P2 is equal to 1 by F2. Now the equation F is equals to F1 plus this equation 1 by F is equals to 1 by F1 plus 1 by F2 minus D F1 F2 becomes 1 by F is P. P is equals to P1 plus P2 minus D P1 P2. Yeah, this is the equation. P is equals to P1 plus P2 minus D P1 P2.